Welcome back to e-Shikshana VTU program on computer aided engineering drawing. In previous session, we have completed the problems on projection of points. In this session, we will start working for projection of lines. Before going to projection of lines, I am very much sure that we are working this projection of lines only in first quadrant, okay, as per the syllabus. Now, let me discuss first quadrant and related aspects. Now, let me take first quadrant. This is vertical plane, this is horizontal plane. You know very well that this particular intersection line is referred to as reference line. In future, we have to stick to a particular pattern of XY line and VP-HP documentation. Now, how exactly we do it? Now, consider this particular system. This is vertical plane, this is horizontal plane. Now, let me project horizontal plane itself on VP. Where exactly it coincides? It coincides with XY line. So, the reference is this. See, I have in this particular figure VP, HP, I project the HP itself on VP, it coincides with the XY line. It coincides with XY line. So, in this figure, we can see the VP area and we cannot see the HP area because this is 2D, we have projected on XY line. This XY is referred to as HP. Next, let me project the VP onto HP. See here, see again same figure model works for us. This is VP, this is HP. Let me project VP on HP. It coincides on reference line only. See, just observe here. This is HP area and this is XY line, this is VP. Now, if you do like this, this particular XY line is identified as VP HP. Whenever you are in this area, XY line acts as HP. Whenever you are in HP area, XY line acts as VP. That's why I always say XY is double acting. So, whenever you keep a line in this way, that means this line is perpendicular to VP. Where you project it, you will get it like this. Then the line comes like this. So, this line is perpendicular. We have to forget VP now. We have to concentrate on XY line. So, with respect to this HP area, XY line is VP. So, it is perpendicular to VP. Suppose that it is inclined to VP. Then you will get the projection on HP and rotate. You will get the inclined line. You can say this inclined line is inclined to VP. I have to address to the VP, not to the area here, XY line. So, projection to be addressed with XY line. Similarly, if I keep it like this, then this becomes parallel to VP. So, here projection is this, then you will get parallel to XY line. Now, I represent the same in this figure. Just observe here. This is VP area and this is HP area. Whenever you draw a line perpendicular to XY in this system, then this is referred to as the line is perpendicular to HP. Now, the line is parallel to HP and line is inclined to HP. Always angle refers to the other side. That means in this case it is XY line. Similarly, if you have any line, particularly all these are true lengths. Okay. So, this particular line is perpendicular to VP, parallel to VP and then inclined to VP. Inclined to VP by phi angle, that is the convention we use, and inclination to HP we use theta. So, in future, whenever you draw a line below XY line, that means that is perpendicular to or inclined to or parallel to VP line, that is vertical plane. If you draw above, always it is with respect to HP. So, this is how you can understand the straight lines in a better way. Now let me work some of the problems. So simple problems within first quadrant, that is all straight line problems are dealt in first quadrant only with some simple models. Let us understand projection of straight lines by using simple models. I have the models with simple examples. For example, I have the line which is placed on HP. This is horizontal plane, this is vertical plane. Placed on HP. Now the line is 50 mm in front of VP, or in general some distance in front of VP and on HP. Then what is projection of the line on HP? This line itself is top view. Now I will project it onto the VP. It coincides with the XY line. So this is front view and this one is top view. Let me remove the actual line and then rotate the horizontal plane by 90 degree. So you will get the projections of the line on HP and VP. This is front view, this is top view. Now let me take this again and tell you, this is the line on HP in front of VP. Now this is top view and this one is front view. So now I can say the line is on HP and parallel to VP by some distance. Next, I will take up the reverse of this situation. Reverse of this situation. Line is on VP and line is on VP and this itself is front view. A dash, B dash is front view. Line AB, A dash, B dash is front view. Next, the projection of the same is on XY line because it is on VP. Then AB is top view, A dash, B dash is front view. Now let me rotate this and this is the projection of a line with the line is on VP and 50 mm above HP or any certain distance from HP. So this is about the simple problems on straight lines. Now let me take a simple problem again. Now this situation is line AB is touching both HP and VP. AB is touching both HP and VP. The line is touching both HP. Since it is touching both HP and VP, the single line is going to represent the front view and top view. So this is A dash, this is B dash. Same line is AB. So now I will make this 2D on flat surface. Rotate the HP by 90 degree. You will get the front view as A dash, B dash, top view as AB. Next model is on a realistic model. This in space, the line is in space. Okay. Now actual line is AB, project it, you will get A dash, B dash, and you project it on HP, you will get AB. Suppose that this is 50 mm above HP and 30 mm in front of VP. So what about the distance of the front view above XY line? That is 50 mm. Then this one is 30 mm. Now you rotate, you will get the top view and front view. This is A dash, B dash, this is AB. So this is how you can understand straight line concept very easily using these models. Now let me take up next model. The line is on HP and inclined at some degree to VP. And what about the projection of the line which is on HP, which is inclined to VP by some angle, say phi. Now the projection length is apparent length. The projection length is apparent length, and A dash, B dash is its view, and the corresponding top view is this itself, the impression of this line itself. Now I will remove the actual line and then say AB is top view, A dash, B dash is front view, then rotate. Now I can say the line is on HP and the line is inclined to VP by phi. Okay. Now the next model is reverse of this. The line is on VP, inclined at some degree to HP. You can say this is line is on VP and inclined at some degree to HP. And one end of the line is 10 mm above HP. Now, what is top view? Top view is on XY line because it is touching VP. It is on VP. Projection of the line is on HP and it is on XY line. Now, AB is top view, A dash B dash is front view. Now, I can rotate this and say this is the final answer. A dash B dash is front view, AB is top view. Now, I can repeat AB is on VP and line is inclined at some degree to HP and the line is having one end A 10 mm above HP. Okay. This is how you can give the information regarding the straight line problems. Next, this is the situation. The line is inclined at some degree to HP, fine. Say 30 degree to HP or 45 degree to HP. Then project it, you will get top view. This is the top view. Now line itself is 20 mm in front of VP. Okay, line itself is 20 mm in front of VP and inclined at some degree to HP. This is front view and this one is top view. Apparent length is top view, the true length is front view, and since it is touching HP, one end is touching XY line. So this is the real situation. I will remove the actual line and then rotate the horizontal plane. So this becomes AB, top view, apparent length, A dash B dash is front view. So now I will repeat, the line is parallel to VP, inclined at some degree to HP. One end of the line is on HP. So like this you can go for different types of discussions. Now let us take this model. Now the line is inclined at some degree to VP. Okay, inclined at some degree to VP and parallel to HP by 10 mm. That means the line itself is 10 mm above HP. So the projection of this line on HP is true length, that is AB is the true length, projected length, that is true length. Again projected length on VP is apparent length because this is inclined at some degree to VP, the projected length will be less. So suppose that this is 80 mm is there, this is around 60 mm, all depends on the angle. Now I can say after rotating this, this is the final projection, A dash B dash is front view and AB is top view. The line is parallel to HP, inclined to VP by 45 degree or whatever the angle given. Now the line is touching VP, that is very important. That will be given by the question. A is on HP, on VP or some distance above HP or in front of VP, like that. Then in this case the line is touching VP. So that's why in top view A is touching XY line. Next comes the line touching HP, inclined to, line is touching HP, inclined to HP and parallel to VP. So this is what the top view is, apparent length, and it is line itself is 20 mm in front of VP, say the projected length is true length and top view is apparent length. Now rotate this. Now I can say the line is inclined to HP by 45 degree. The line is parallel to VP and one end of the line is touching HP. So this is how you can understand the simple positions of the straight line. This helps you to understand the regular problems on straight lines. Now you can say this is on VP and the distance is, one point is 10 mm above HP and the corresponding front view and top view. And again here we have the line is inclined at some degree to VP, inclined at some degree to on HP. Now the front view is touching XY line because it is on HP and inclined at some degree, and one end is 20 mm in front of VP, say. Now I can say the line is on HP and inclined at some degree to VP. Yes. Now take the two more important problems, simple problems, and discuss with simple models. Now, let me have the line in space. Nothing is touching HP or VP. One end is 20 mm in front of VP and 10 mm above HP. End A, this is end A, this is end B. This one is end A is 20 mm in front of VP, 10 mm above HP. And line is inclined at some degree to HP. Now projected length is true length. The apparent length is on HP. That is, top view is apparent length, front view is true length. That means whenever a line is parallel to a plane, on that plane you get the true length. Whenever a line is inclined to a plane, on that plane you get apparent length always. Now projected, this is apparent length, this is true length. Now I can rotate by 90 degree and this is the final projection. Now I can give the status of the line very easily. The line is 20 mm in front of VP. One end of the line is 10 mm above HP. And the line is inclined at 30 degree to HP. So this is how the problems you get in exam or regular classes. Now this is the situation where the line is inclined to VP by 30 degree and the line itself is 20 mm above HP. That means all points of the lines are 20 mm above HP and one end is 15 mm in front of, that is end A, 15 mm in front of VP. Now projected, you will get apparent length because it is inclined to VP. On VP you get apparent length, that is front view. What is top view? It is true length, AB. AB is top view, A dash B dash is front view. Now let me rotate and get the final projections. This is A dash B dash and this is AB. The line AB is inclined to VP and parallel to HP. One end of the line is 20 mm above HP and 15 mm in front of VP. So these are the various ways of understanding the straight line. Now I will take up one simple problem and discuss how to draw the projections. Let me write a problem, simple problem. A line 80 mm long has one of its ends 10 mm above HP. 10 mm above HP. And the line is 30 mm in front of VP. In front of VP. Draw the projections. When the line is inclined at 30 degree to HP. 30 degree to HP. Okay. Now this is the problem we have. So to solve this problem, it's a simple problem on straight line. Draw XY line as usual, as we discussed already. The XY line must be drawn properly and with the VP-HP reference. That is the regular pattern we have to have. Okay. XY. Now, let me fix one line. 10 mm above HP. Since the name of the line is not specified, purposefully I have done this job. Generally you get AB, PQ, MN like that. Now let me add line AB 80 mm long as its ends 10 mm above HP, etc. Now let me take this and what? A dash is one end of the line is 10 mm above HP. 10 mm above HP. And the end A itself is 30 mm in front of V because the line is inclined at 30 degree to HP and the entire length of the line is 30 mm in front of VP. That means end A is also 30 mm in front of VP. Draw this line. Okay. This is A. Then fix this. This is 30. End A is fixed. Now the line length, true length of the line is given as 80 mm. Now fix 80 mm long line. So that means in manually what you have to do is draw a line, thin line using protractor or mini drafter, whatever. Then fix 80 mm because the front view is true length because it is inclined to HP and parallel to VP. So this is the line, you get true length and you get apparent length on HP. Now first let me fix 80 mm long line. Okay, this is 80 mm say. Now let me name this as B dash. A dash, B dash is front view. Since it's a simple problem, how to dimension this? You draw perpendicular lines from both ends, then draw dimensioning line. This is 80. Okay. Further, if you have inclination to VP and all, then you will not do it. At the end, you can do. Now, draw projection from this. Where you expect the top view? Since he says the line is 30 mm in front of VP. Now, if I take up the model which we have discussed earlier, see, this is the model I have. Yes, this is the model I have. The line is, actual line is this, it's front view. Then the line itself is 30 mm in front of VP. The one end is 10 mm above HP. This is the model I can use for understanding purpose. So, front view, top view. Top view is apparent length, front view is true length. So, this is the front view and top view. Same thing I am explaining here. You can understand very easily. Now, I have to draw parallel line to this and name this as B. That means you have the true length of the line in front view because it is parallel to VP. Whenever a line is parallel to a particular plane, on that plane you get true length. Since it is inclined to HP, you are getting apparent length. So apparent length you need not measure unless they give the question what is apparent length, then only you measure. Otherwise, this is front view, A dash, B dash is front view, AB is top view, and corresponding angle you have taken, you should mention clearly theta equal to 30 degree. So now I can explain clearly for this without looking at the question. I can explain the line is inclined at 30 degree to, you must mention always VP HP. This is very important. 30 degree to HP. The line is parallel to VP and 30 mm in front of it. Okay. So one end of the line is 10 mm above HP and as such 30 mm in front of. This is how you can define. How to draw the side view of the line? It's very easy. Draw line x dash y dash. X dash y dash, draw. X dash y dash, that gives you the RPP value. X dash y dash. This is VP of RPP, this is HP of RPP. Yes. Now draw 45 degree line. Then project AB up to 45-degree line only, and then project this up. Then project B directly towards RPP. This is B double dash, and this one is A double dash. Finally, you join this. So this gets you side view on RPP. This is RPP area. This is left view on right plane. So this is first angle projection we are working. If they draw the right profile plane, you must look it from the right view, and keep it on the left plane, and vice versa. Here this is front view, this is top view, and this is side view. Then the remaining problems, simple problems, we will take up on computer work. Okay, when it comes to projection of lines, I am very much interested in giving some important points. Here I have two figures, and in this figure I have lines which is perpendicular to xy, parallel to xy, and inclined to xy. This depicts the line is particularly perpendicular to HP and parallel to HP and inclined to HP. That's why I kept HP with a big letter, more emphasis on HP. So as I told you earlier, this length is actually referred to as projection length. Whenever a projection length is true length, then definitely it is perpendicular to HP, and this one is parallel to HP, and this is inclined to HP by theta. Same way I can say, whenever lines are available, projection lines are available in any of your problems, what is derived or you obtain or you draw initially, if these are true lengths, then naturally this is perpendicular to VP and parallel to VP and inclined to VP by phi, angle phi. Normally inclination to HP we represent by theta, and this is for inclination to VP, phi for VP. Now I will take you to the different problems on the lines. Before going to that, whatever I explained using simple models, I will take it on computer, and this particular problem is 50 mm above HP and 30 mm in front of VP. The line, the red color one is representing the actual line, and blue color lines are representing projections. This is actually front view, this is top view. This is why we call this orthographic projection. You see, perpendicular to the principal planes of projection, this is VP and HP, and this is front view, this is top view. Now let me name this particular line. A dash, B dash is front view, AB is top view. If you rotate this, definitely you get the top and front views. Now let me take one by one the particular case. A line is 80 mm long, is on HP and 40 mm in front of VP. That means 40 mm in front of means it is parallel to and in front of VP by 40 mm. So this is the line, okay, is representing top view, and since it is on HP, the projection line should be on XY line. This is A dash, B dash, is front view. Now let me take you to the reverse problem of this, that is 80 mm long on VP and 40 mm above HP. That means the 40 mm above HP and parallel to HP. So parallel to HP and on VP. So this is 40 mm. This is how you represent the projection of this problem. And next comes the line is on both HP and VP. There is no distance from both HP and VP. So single line on XY representing A dash, B dash as well as AB. So here the line is 40 mm above HP, 20 mm in front of VP. That means both are parallel to XY line. So this is again the problem on straight line, which is having some distances from HVP parallel to it. So next comes the line which is inclined to VP on HP. See here, it is on HP and inclined at 40 degree to VP. One end of the line is 20 mm in front of VP. So this one now we take it as the distance of one end of the point. You can even give the distance for B also. If nothing is specified, like particularly end A and B, you can start like this, okay, and draw the projection. There are alternate solutions for each problem. Here we have 8 mm long is on VP, the line itself is on VP and inclined at 40 degree to HP. So inclination to HP, whatever you do here, that is for VP area, that is for HP. So one end of the line is 20 mm above HP. So this end A is 20 mm above HP. Some other problem is there. Yeah, this is some 50 mm, 15 mm above HP and this one is 20 mm in front of VP. So here is, okay, there is some problem. Line is 20 mm above HP and one end of the line is touching VP. This problem. Or you can say simply on VP. On VP. Different problem has come. A line is 80 mm long, is 20 mm above HP and inclined at 40 degree to VP. One end of the line is on VP. Yes. Now we have a line 80 mm long is 20 mm in front of VP and inclined at 40 degree to HP. Okay. Then one end of the line is 20 mm above HP. Here it is actually 15 mm. Okay, I think some wrong. 15 mm above HP. One end of the line is 15 mm above HP. The line itself is 20 mm in front of VP. The line is inclined at 40 degree to HP. Here, a line 80 mm long is 20 mm above HP and inclined at 40 degree to VP. Here is inclination to VP is given and one end of the line is 15 mm in front of VP. So all are having distances can be varied for this. It can be on HP, on VP or 15 mm or 20 mm in front of, above, etc. Accordingly you draw. And inclination, whatever it is given for VP, you must keep it below XY line, that is on HP area. And if the angle is given for HP, you must take it above XY line, that is VP. Once you start working the problems on straight lines, you will get the idea of drawing